Welcome to This Explainer. Today, we're doing something really cool. We're diving into how literally anyone can become a digital director. And get this, without writing a single line of complex syntax. If you've ever thought about making your own video game, animating a story, or even just kind of wondering how software actually ticks under the hood, well, you're in exactly the right place. We're going to explore a total game changer of a tool called Scratch.
Now, it sounds a little crazy, right? Can you actually code without typing a single word? Well, the answer is a massive, resounding yes. And honestly, it completely flips how we learn to program on its head. Look, traditional coding can be, frankly, pretty intimidating. I mean, you miss one tiny comma, maybe a semicolon, or just misspell a command, and boom, the whole program crashes. But what if we just bypassed all of that? What if the pure logic of coding was completely separated from all that strict, unforgiving typing?
That's exactly where Scratch comes in. Think of it like a giant digital box of Lego bricks. Developed by the brilliant folks over at the MIT Media Lab, Scratch is a visual, block-based programming language. So instead of staring down a terrifying blank text document, you get this incredibly vibrant workspace. You literally snap commands together and get immediate visual feedback. It's so intuitive, which means you're going to spend way less time pulling your hair out over syntax errors and way more time actually creating and experimenting.
So here is our roadmap for today. We'll be covering 1. Coding made visual. 2. Touring the Scratch Theater. 3. The anatomy of blocks. 4. Colors of code. And finally, number 5, the backstage editors.
All right, let's kick things off with Section 1, Coding Made Visual.
The absolute magic of Scratch is how it handles the code itself. Instead of typing, students just drag and connect these colorful blocks that represent different commands. It completely removes the intimidation factor. You're still learning all the core fundamental computer science stuff, loops, variables, conditionals, but you're doing it in a way that just feels like playing. It's a real game changer because it totally democratizes the ability to create software for learners of any age.
Moving right along to Section 2, Touring the Scratch Theater.
Okay, I want you to imagine you're the director of a major stage play. The Scratch interface is basically your theater map. It shows you exactly where your actors hang out, where the performance actually happens, and where you'll be writing the script. Now, at first glance, yeah, it might look like there's a whole lot going on, but it's actually beautifully organized into 3 main areas. Let's break those down so you know your way around the workspace.
Up in the top right corner, you've got the stage. This is the literal center of your universe. It's a canvas that's 480 pixels wide by 360 pixels tall. It runs on a standard X and Y coordinate system, with 0, 0 sitting right smack in the middle. This space, this is where your code executes. It's where your characters move, where they interact, and where they put on a show for the audience the second you hit that green start flag.
Right below the stage is the sprite list. You can think of this as your green room. In Scratch, a sprite is really just your digital actor or an object. It could be a cat, a rocket ship, a clickable button, or even just a line of text. The sprite list is your hub to add, select, and manage all the cast members of your play. You can grab them from a huge built-in library, draw your own from scratch, or even upload images straight from your computer.
And then, taking up the whole center chunk of your screen is the code area. This is the director's chair. When you select a sprite from your green room, you drag code blocks right into this space to build out the exact sequence of actions for that specific actor. Each sprite gets its very own unique script, which means they can act totally independently, or you can have them interact with each other out there on the stage.
Which brings us to Section 3, the anatomy of blocks. Let's actually look at how we build these scripts.
So because Scratch relies heavily on basic sequencing, every single script is going to flow from the top down. You'll always kick things off with a rounded hat block. These are your triggers, like when the green flag is clicked. From there, you snap in your middle stack blocks, which are the actual actions happening in the scene. And then usually you'll cap it all off with, you guessed it, a flat-bottomed cap block. This just tells the program, okay, stop running this specific script. It's incredibly logical once you get the hang of it.
And here's the absolute genius of Scratch's design. The shape of every single block tells you exactly what it does. They're literally puzzle pieces of logic. And because of their shapes, you physically cannot snap 2 incompatible commands together. For example, you have these hexagonal Boolean blocks. They handle true or false questions, right? Like, is this sprite touching the color red? You just can't jam a hexagonal Boolean block into a rounded reporter block slot that's looking for a number. The visual design actually prevents you from writing broken code. How cool is that?
Let's keep rolling with Section 4, Colors of Code.
So the block palette is broken down into 9 intuitively color-coded categories. Say you want your character to take a walk. You immediately look for the blue motion blocks. Need to do some quick math or generate a random number? Bam! You head straight for the green operators. Want to trigger something when the spacebar is pressed? That's going to be a yellow event block. At just a quick glance, you, and anyone looking at your project, know exactly what a chunk of code is trying to do, purely based on its color.
Now, you might be wondering, is this just for simple stuff? Absolutely not. It is surprisingly powerful. Just to give you an idea, using the orange control blocks, you can actually create up to 300 clones of a single sprite simultaneously. No way, right? It's an incredible feature if you're getting into game design. Instead of agonizing over programming 300 individual laser beams or an entire swarm of alien enemies, you just program one and literally tell Scratch to copy it. It's such a fantastic way to introduce object-oriented concepts without the headache.
All right, on to our final act, Section 5, the Backstage Editors. Because believe it or not, Scratch is way more than just a coding tool. It's practically a full multimedia creation suite.
When you pop over to the Costumes tab, you'll find a built-in graphics editor featuring 2 very different tools. On the left side, there's Bitmap mode. That one's pixel-based, kind of like Classic Paint. It's great for painting textures or tweaking photos, but keep in mind, it's going to get pretty fuzzy if you zoom way in. Then, on the right, you have Vector mode, which is actually Scratch's default. Vector relies on underlying math to draw shapes. This means you can scale your cartoon characters to be as massive as you want. And those edges, they will always stay perfectly crisp and smooth.
And, I mean, what's a good play without some audio, right? You've also got a fully functional sound editor right there backstage. You can record your own voice directly into the browser, easily trim out any awkward dead air, and then start playing with some really fun filters. You want your main character to sound like a machine? Just throw on the robot effect. Looking to create some weird alien language? Just hit the reverse button, and it plays your audio backward. It really gives you total creative control over the whole vibe of your project.
But when you step back, everything we've talked about, the whole interface, the vibrant blocks you're connecting, all those assets you're tweaking backstage, they all rely on one absolutely fundamental rule of programming: sequencing. The computer is going to do exactly what you tell it to do in the exact order you tell it to do it, straight from top to bottom. Scratch just takes that sometimes daunting process of giving instructions and makes it incredibly visual, completely logical, and honestly, just really fun.
So, with your theater fully prepped, your digital actors waiting patiently in the wings, and a solid grip on how to sequence your very own colorful script, the true power is totally in your hands. Scratch strips away the usual barriers that keep people out of computer science, so you can just focus entirely on your logic and your own creativity. So, the only real question left to answer is, what amazing story or game are you going to bring to life next? Thanks so much for joining me on this explainer, and hey, happy coding!